Welcome to this comprehensive guide for beginner C# developers. We'll focus on collections, fundamental for managing data effectively in your programs. This tutorial covers key concepts. Understanding how to efficiently manage groups of data is fundamental to writing efficient and organized C# code. This skill is crucial for building robust applications. Collections are powerful data structures allowing you to store, retrieve, and manipulate multiple related items under a single variable. They organize data efficiently. Collections are crucial for tasks ranging from managing user inputs to processing large data sets. Their utility spans many programming challenges, enhancing data handling. In this tutorial, we will explore two primary C# collection types, static arrays and dynamic lists. We'll compare their features, benefits, and ideal use cases. We'll cover their declaration, practical usage, inherent limitations, and when to strategically choose each one. This will help you make informed programming decisions. Let's begin our journey into C# collections by first understanding static arrays. These are foundational data structures, essential for many programming tasks. A static array is a collection of elements of the same data type, stored in contiguous memory locations. This sequential storage allows for very fast and direct access. The defining characteristic of a static array is its fixed size. This capacity is determined at creation and cannot be altered later, making it rigid. Once an array is declared with a specific capacity, you cannot add or remove elements to change its total size. Its capacity remains constant throughout its lifetime. To declare an array, specify the element type followed by square brackets, then the array name. For example, InArrayNumbers declares an integer array. Initialization involves using the new keyword and specifying the array's size. For instance, newInt 5 allocates space for 5 integers, establishing its fixed capacity. This creates an array named numbers that can hold 5 integer values. Each of these 5 slots is now ready to store a distinct integer from index 0 to 4. Alternatively, you can declare and initialize an array directly by providing initial values within curly braces. The array size is then automatically determined by the number of elements provided. In this case, the array size is automatically determined by the number of elements provided. This simplifies setup when your data is known up front, eliminating manual size specification. Accessing individual elements in an array is done using their index, which always starts from 0. The first element is at index 0, the second at 1, and so on. For example, numbers 0 would retrieve the first element, and numbers 2 would retrieve the third. This zero-based indexing is crucial for precise element access. Attempting to access an index outside the array's bounds will result in an index out-of-range exception error. This occurs if the index is negative or exceeds the array's length, indicating invalid memory access. Modifying an element is straightforward. Simply assign a new value to a specific index. For instance, numbers 1 equals 25 updates the element at index 1 directly. This operation directly updates the content at that memory location. It's an in-place modification, making element updates very fast without creating new structures. The primary limitation of static arrays is their fixed size, which can be restrictive when dealing with dynamic data. This rigidity makes them less adaptable to changing data quantities. If you need to store more elements than initially allocated, you cannot simply expand the array. Its fixed boundaries mean you must create a new, larger array instead. This limitation makes arrays less suitable for scenarios where the number of items changes frequently. For dynamic data, a more flexible collection type is often required. Now, let's explore dynamic lists, specifically list T, a flexible and powerful alternative to arrays. This class is ideal for managing dynamic data efficiently. Unlike arrays, list T can grow or shrink in size as needed, making them ideal for varying data quantities. This dynamic behavior simplifies data management significantly. As you don't need to predetermine the exact capacity. The list handles capacity adjustments automatically, freeing the developer. Creating a list T is straightforward, requiring only the type of elements it will hold. For example, list string names list equals new list string creates a list for strings. The string part specifies that this list will store strings. This generic type parameter ensures type safety, preventing incorrect data types from being added. Adding elements to a list T is done using the add method, appending them to the end of the list. This operation is typically very fast and efficient. You can add as many elements as you need without worrying about running out of space. The list intelligently manages its internal capacity for you, expanding as required. Removing elements from a list T can be done in a couple of ways. You can remove by value or by specifying an index, offering flexibility. The remove method takes the actual value of the element you want to delete. It searches for and removes the first occurrence, returning true if successful. The remove at method, on the other hand, removes an element at a specified index. For example, names list that remove at removes the first element, shifting subsequent items. Accessing elements in a list T is similar to arrays, using zero-based indexing. You can retrieve elements by their position, just like with arrays. You can retrieve or modify elements by their position, just like with arrays. This consistency makes list T easy to learn and integrate into your code. The main benefit of list T is its dynamic nature, simplifying data management without worrying about capacity. It automatically handles resizing, making it highly adaptable. This flexibility significantly reduces the complexity of handling collections where size changes frequently. Developers can focus on application logic, not low-level memory management.
Next, let's understand how resizing applies differently to arrays and lists. Their approaches to changing capacity are fundamentally distinct and important to grasp.
Since arrays have a fixed size, resizing an array actually means creating a completely new, larger array. You cannot expand an existing array in place. You then must manually copy all elements from the old array to the newly created one. This is a developer-managed, explicit process requiring careful implementation. This can be achieved using a loop or the array copy method. The array copy method offers an optimized way to efficiently handle bulk transfers of elements. This manual process can be cumbersome and less efficient, especially for frequent resizing operations. Each resize involves a complete data transfer, consuming CPU cycles and memory. It also requires careful management to avoid data loss or errors during the copying process. Any oversight could lead to critical data corruption or subtle bugs. In contrast, list T handles resizing automatically behind the scenes, abstracting away this complexity. It intelligently manages capacity without explicit developer intervention. When a list T runs out of space, it internally creates a new, larger array and copies elements. This process is transparent to the user, ensuring seamless growth. Typically, the new capacity is double the old one, optimizing for performance while minimizing frequent reallocations. This strategy balances memory usage and speed effectively. This automatic management makes list T much easier to work with for dynamic data. Developers can focus on application logic, not low-level memory details. Finally, let's cover some helpful tips for choosing between arrays and lists in your C# projects. These guidelines will assist you in making informed decisions. Use arrays when you know the exact number of elements at compile time and the size won't change during execution. They are ideal for fixed-size data sets. Arrays are also preferred when performance is absolutely critical, offering slightly better performance due to direct memory access. This can be beneficial in highly optimized scenarios. This direct access can be beneficial in highly optimized algorithms or low-level programming. It provides a direct pipeline to data where every nanosecond counts. Opt for list T when the number of elements is unknown or will change frequently during execution. Its dynamic nature truly shines in such unpredictable scenarios. List T provides convenience and flexibility, making it a common and often preferred choice for most dynamic data scenarios. Its ease of use and adaptability are significant advantages. While list T has a slight performance overhead due to automatic resizing, it's often negligible for typical applications. The benefits of flexibility usually outweigh this minor cost. For best practices, always consider the specific requirements of your application before making a choice. Understanding your data's behavior and constraints is key to optimal selection. If you're unsure, list T is generally a safer and more flexible default choice for beginners. It minimizes common pitfalls associated with fixed-size collections, offering more forgiveness. Understanding both static arrays and dynamic lists is crucial for effective C# programming. Each has unique strengths, and knowing when to apply them appropriately is key to robust code. By mastering these fundamental collection types, you'll write more robust, efficient, and maintainable code. This comprehensive knowledge empowers you as a developer, enhancing your programming skills. Keep practicing with different scenarios to solidify your understanding. Hands-on experience is the best way to build confidence in choosing the right collection for the job. Thank you for joining us in this tutorial on C# collections, exploring static arrays and dynamic lists. We hope you found it informative and empowering. Happy coding!